Oh, crap. This is recording. Oh, okay. Hello, again. Sorry I wasted 20 seconds of your time, and possibly more. What was I going to do right now? Alright, finish the last bit of the Electrophorus. Mr. Fork, I don't care about your pronunciation. This is how I say it, because it's fast. Alright, so now, the second half of the Electrophorus adds a big straw, a piece of string, and a piece of that straw wrapped around aluminum foil. Why the straw is wrapped around aluminum foil is because, straw, it acts as an insulator. However, we don't need it to be insulated. We want it to conduct. And that's the reason why it moves. It is wrapped in a conductor. The straw serves as something to insulate, or does it serve as an insulator? No, it does not. It is an insulator. I suppose you could say it serves as an insulator, but it does nothing more than insulate. The string is attached to it, neutral charge there, as is the straw, and its only purpose is to dangle the... do I want to keep saying aluminum straw? And I definitely don't want to say ass, because, that's the initials of it. You know what? I'm going to refer to the aluminum foil wrapped around the straw as just straw, because the other straw is pointless in this entire experiment, other than serving as an extension so that the string can dangle. So, aluminum foil wrapped straw is now referred to as straw, just for no confusion at all. Okay. Straw. Now, placed in this thing, that's a very uncomfortable noise. That's uncomfortable as well. Oh, it's worse than nails on a chalkboard. Alright. Wrap it around, wrap it around. No, I am not doing this experiment again. If you want to see the experiment, watch part 2. Do not listen to anything I say, just watch it. For the sole purpose of watching this thing move. Alright, so, pay no attention to the fact that it's dangling now. In the experiment, when it's connected to the styrofoam plate, it is attracted to this. Wonder why? It's because somewhere around here, while it's dangling, there are positive charges here. And while it's connected, as we said before, the negative charges are here. That's why it's attracted. Same attraction, same difference, nothing more, nothing less. When it's up above, take the styrofoam plate off. I know it was off before. Just leave me alone. Now, when it's off the plate, you notice in the other man's video, I didn't do this in mine, but in the other man's video, it gets repelled. Wonder why there? Because now both positive and negative charges are there, because all the negative charges have flown throughout here. There's no other induction here. There is no induction because the styrofoam plate is no longer attached. The charge was never disconnected. Now it is a neutrally charged object, and that's why it's repelled. Some of the positive charges are here, some of the positive charges are here, and that's why it is repelled. Now, put the styrofoam plate back on, and it's connected. Now, what happens there, as you saw before when I was on the table, I put my finger to it, and it goes back and forth like crazy, like a little kid deciding which parent to love after the divorce. Because they keep making offers. Please do not demonetize me for that or look too much into that. I'm just using it as a funny example so people won't get entirely bored by this. Alright. Oh, I can feel my teacher giving me an F right now. Alright. So, while that ball is bouncing, or not bouncing, I should say traveling back and forth, it's because of the negative charges in that. It was attracted to the plate, but like I said in part 2 and I think a little bit of part 3, it's not necessarily like a magnet, even though there's an electromagnetic force that's greater than gravity when you lift the styrofoam, lift it up by the styrofoam cup. Disregard the electromagnetic aspect of this project. What happens is that I have my finger. We have a ball. We have a straw. We have a straw. The straw is attracted to my finger, and when it's attracted to the plate, some of the negative charges on the plate jump onto the straw. So, just like before when it shocked my finger, it shocks the ball. Even though you can't hear it, I can't even hear it or see it, but that's how the ball moves. You have so much negative charge that, sure, one charge at a time pushes it away until it is mostly negative. While it pushes away, it delivers those charges to my finger. Now my finger is mostly negative charged. So it goes back, picks up more charge, takes it to my finger, takes the charge there. It's a constant give and take. So what that is, it's, well, what did he say? Induction was the process by which an electrical conductor becomes electrified when near a charged body. Induction is only taking place through the styrofoam plate and the aluminum pie plate. Induction is not taking place when my finger gets charged. It is when an electrical conductor. Am I electro or static shock in the DC or Marvel universes? No. I am Dan. Skinny, slightly fast, on the rugby team, gets his butt kicked a lot. Dan. And I am not a conductor. So now, is there conduction taking place? Yes. Throughout the pie plate and now through the foil-wrapped straw. Is there any... I said conduction, I said conduction. Is there grounding? Yes. Assuming that I get the charge delivered in my finger, and afterwards I pick up the pie plate, get the charge in my finger again, and ground it. Otherwise, it's just the Electrophorus itself that is grounded. Wow, this went a lot smoothly than I thought. Alright. Bottom line. This is my final word throughout this entire project. Oh, speaking of which, the tape is both positively and negatively charged in this entire experiment. How I know? Because if I didn't explain it last time, forgive me, I got memory loss. I hit my head too many times while doing this video. Tape, while it's charged, while this thing is inductively, I'm going to say inductively charged, positive charges reside in the center. The only way for something to be attracted to positive is if it's the opposite charge, negative. And what happens is that the tape could be negative. It has to be negative. Now, it also could be... No. I was about to say entirely negative, but that would be wrong. Because during that tape lab we did a tape sandwich, basically, for lack of a better term. We did a tape sandwich where we pulled the pieces of tape apart. Now, both pieces of tape were positively and negatively charged. Did I make a tape sandwich by putting these things on? No. I would have wasted more time than I already am. This is both positively and negatively charged because in a tape sandwich, you pull two pieces of tape apart, and sometimes, more often than not, negative charges go to the other tape and positive charges go to the other tape, which means that one tape has positive, one tape has negative. That's how you got repelling and attraction. Repulsion and attraction, basically. And that's how that experiment worked. With the lucite rod, the foil, the paper, and both pieces of tape, and the PVC. That's not happening here. No tape sandwich, which means negative charges are sticking to the pie plate, and positive charges attract to the styrofoam cup. That's how it's still sticking. That's how I can take this straw, ring it around everywhere, and all that comes off is the straw. Alright. Thank you for the second chance at making this, because I probably will pass this project now. Alright. I hope that made sense, and I really hope I get a good grade on this. Alright. See ya. Once again, this will be the final part. Do not expect any more videos out of me, especially from this remote learning thing, because the last thing I need to do is stare at a screen for more than 8 hours a day. Alright. Goodbye.